everyone in this very special workshop. I hope that all of you are fine and Christmas preparations are doing well. It was a very good strategy to plan this presentation together with Victor's one, because we both did a research on quantitative geosite assessment based on a brand new theoretical concept. Besides the regular parts of evaluation, we incorporated the opinion of geotourists in the assessment individually at every examined geosite. Although the topic is a bit dry and mathematical, I will try to make it interesting, and I encourage you to put it for a test after the pandemic. Before we start, I would like to tell a few words about myself. My name is Márton, and I am from a little village called Várasszó in northern Hungary. I started my university studies at 2014 at Eötvös Loránd University in Budapest and got my master's degree as a cartographer in 2019. Currently, I'm a second-year PhD student at the Earth Sciences Doctoral School at Eötvös Loránd University under the guidance of Professor Gáspár Albert. My doctoral topic is about the automatization and quantification of geodiversity assessment and geosite assessment, and I'm also interested in drone mapping and photogrammetry modeling, web-based GIS, and I'm getting to know Android programming in Java. In the bottom of the slide, you can see some publications we have made in the topic of geoheritage and geosite assessment, but there are a lot of more on ResearchGate and any other platforms. First, I would like to give a short overview on the basic concepts related to geoheritage and geodiversity and geoconservation. If an element of geodiversity has scientific values, for example, geological or geomorphological values, we call it a geosite if it is in situ, a key section for instance, and the geoheritage element if it is ex situ, for example, a mineral collection in a museum. Among scientific values, we can talk about additional, for example, cultural or religious or touristic values too. Geoconservation stands for the conservation of natural objects of both types of values. However, geoheritage focuses on objects that have scientific values. Geosites usually have additional values among scientific ones too. This is the basis of their public interest and touristic use. Before establishing a geopark or a nature conservation area, it is fundamental to have an assessed group of geosites. There are two basic approaches evaluating scientific and tourist properties. The qualitative assessment, that is a rather subjective way mainly done by experts of the certain area, and the other is the quantitative assessment that evaluates the geosites in a more objective way using numerical methods. This is our sample area, the Bakony-Balaton UNESCO Global Geopark. The closer sample area is within this green border. The surrounding of Lake Balaton is one of the most visited tourist destinations in Central Europe. I'm sure you have heard at least once about Lake Balaton. The northern coast, where our sample area is located, is a part of the Transdanubian Mountains and is well known for its unique geological formations, besides its famous vines and spas. The Bakony-Balaton UNESCO Global Geopark and the Balaton Uplands National Park is responsible for the geological heritage of the area. Our work studies the eastern part, this green rectangle of the Balaton Uplands. The oldest formations here are from the Silurian period, but the most specific rocks of the area, the Permian red sandstone, which is a building stone all over the Balaton uplands was formed during the Permian period. Such rocks as in the Alps can be found here from Mesozoic, different types of limestones and dolomites. And our final aim is to help every designated geosite individually by giving them further development strategies. The geosite assessment model, the GAM, is a great milestone in the development process of quantitative methods. It was worked out in 2011 in Serbia, in the Lazar Canyon sample area. It is consisted of two main parts: main values, the orange values, and the additional values, the light blue colored values. Within the main values group, there are different subgroups: scientific educational values, scenic aesthetic values, and protection values. And within the additional values group, we can talk about two different value groups: the functional values and the touristic values. These subgroups, these 5 subgroups, can also be divided into smaller parameters called indicators. 12 of these indicators are in the main values group, and 15 of these indicators are in the additional values group. Each geosite is assessed by evaluating these indicators and then summing up the values of these indicators, summing up the main values and the additional values, and the geosite assessment model value is given in the end. Well, this geosite assessment model was developed further. The modified geosite assessment model involves the audience into the evaluation process. This was worked out by Tomic and Bozic in 2014, also in Serbia. This involves the audience into the process. The creators of this model interviewed 96 visitors about their personal importance of each indicator of the geosite assessment model. Then these values were summed, and every single indicator got its importance factor, this black factor. If we multiply the geosite assessment model score with this importance factor, we get the modified geosite assessment model score. This importance factor is between 0 and 1. So the maximum value of the modified score can be the original geosite assessment model score, and the minimum can be 0 if we multiply the GAM with 0, but it's not common. Okay, we have assessed the potential geosites of our area using this modified geosite assessment model, but instead of using the universal importance values from the corresponding publication, Tomic and Bozic publication, we decided to produce these values uniquely for each geosite by interviewing visitors. We have selected 9 geosites in our sample area with the highest point from the preliminary geosite assessment model evaluation. We have asked hikers and geotourists about their personal opinion about the sub-indicators of this model, geosite assessment model, on a 0 to 5 scale on each site through personal and online questionnaires. The online questionnaires proved to be usable because when we went on the field, the geotourists didn't really like these long questionnaires and the scientific looking questions, so they usually didn't want to fill the questionnaire at our presence. But when we provided QR codes and URLs on the geosites, they could reach the questionnaires directly in the place. So only the fields came only from people who know the area, who know the certain geosite. In the end, we had 249 online questionnaires and only 18 personal interviews, and the final number of completed questionnaires was 276, between 8 and 64 fields per geosite. In the next few slides, I would like to show some pictures about the 9 chosen geosites. This is almost the oldest rock, this meteorite in Alsóörs village of the Balaton uplands. Only 2 outcrops are recorded all over the geopark of this meteorite, and one is directly in the center of Alsóörs village, but there is no tourism infrastructure built around it. Because of this, the additional values are quite low, in contrary to the main values that are exceptionally high because of the rarity of this formation. This is the Lake Köcsi natural trail. In the picture on the left side, you can see an abandoned quarry. This quarry is built up by the Permian red sandstone that is a common building rock in the area. And on the right-hand side, you see the Lake Köcsi, that is a pond next to this quarry. The quarry is in the background behind these trees. The natural trail goes all over all over the pond and the quarry, and it also holds biological rarities and also the geological formation of the area. The Alsóörs red sandstone nature trail is also built up by this Permian red sandstone, but it is very spectacular because of the outdoor theater built next to the abandoned quarry. Because of the outdoor theater, many people don't even look at the abandoned quarry. They get stuck in the theater, and many of them don't visit the abandoned quarry. This is because the additional values are high here, and the main values are not really high in this area, but a visitor center is built next to this open theater. Well, this Permian Triassic key section is an international interest, answering to Ben's question. It is an international interest because it's quite rare that we can see clearly a border between the Permian and the Triassic. This is the Permian red sandstone, and this is the Triassic limestone over the red sandstone next to Csopak. Unfortunately, this key section is right next to the railway and the highway, and there is no parking lot built next to it. So only experts and only people who know the scientific importance of this site visit this place, and unfortunately it is not safe for larger groups of people. This is Miske Cliff next to Felsőörs village. These tilted layers of Felsőörs limestone are very spectacular, even down from the valley and from the peak next to the cliff. The Felsőörs Forráshíd nature trail is also an international has international interest because of the well-preserved Felsőörs limestone layers. The interesting fact on this map is in the red circle. This photo was taken after we have put the questionnaires on the field. Papers like this, sheets like this were placed next to the geosites. So you can see the QR code and the little description on the paper, and the geotourists could reach our questionnaire through these papers on the field. Szent Király Szabadja Ember Cliff is not a well-known geosite. It is not promoted by the geopark. It was discovered by the assessment work, and the Geopark started to promote it after our geosite assessment model assessment realized that this verse promoting according to the main values. This is a very spectacular large dolomite cliff not far from the village of Szentkirály-Szabadja and Balaton, Almádi. And Balatonfüred Lóci cave is probably the most important and well-known geosite of Balaton uplands and even Bakony-Balaton Geopark. This is a limestone cave, but without karstic processes. There are no stalagmites and stalactites in this cave. The tilted limestone, Füred limestone layers are very spectacular all over every centimeter of the cave. Next to the cave, also a visitor center is under construction right now that will modify the assessment for work at least in the aspect of additional values in the near future. And the last one is the Koloska-Volyand cliffs, also near Balatonfüred. These cliffs of main dolomite are very spectacular. It is a well-known place for, especially for local people. They go out for weekends and spend their free time in the valley. They do some picnic and go up the cliff, but it is hidden from the eyes of people who are not from Balatonfüred. But I think this view worth to visit this beautiful site. These are the 9 geosites that we evaluated in this project. In this graph, you can see the fields per each geosite. The importance value that indicates the importance of a geosite was calculated in 2 ways. So this importance value has 2 meanings. The first, the calculation of the arithmetic mean of fields per indicator per site was quasi-similar to the original MGAM modified geosite assessment methodology. So we took the arithmetic mean of the importances per each geosite. This was the way that we counted the final MGAM score for each geosite. But the second way that we took these importance factors into consideration was that each of the fields were considered as an individual assessment, and the site-wise statistical evaluation could be done on the data set. With neither of the methods, visitors were not differentiated. An answer of an expert weighed as much as an answer of a geotourist. This was important, for example, in the case of this Permian Triassic key section. I said that geotourists don't really know about this geosite nearly, or only geotourists visit this key section. Well, according to the original description of modified geosite assessment model, the importance values reflect a general opinion about the importance of the model's indicators. The authors suggested that the identified importance weights can make the evaluation more objective by pointing out those values which are of a paramount importance for tourists. Tomic and Bozic published new importance values in 2015 with 293 fields. These were produced by summing the 96 fields from the original survey from the Lazar Canyon and adding 197 from other sites. The difference between the 2 importance weights is surprisingly high. You can see it in this table. The original Tomic and Bozic importance values from the 2 years 2014 and 2015 are in the first 2 rows of columns of this table, the blue circles. You can see there are differences between these between these circles, even between the 2 versions from the 2 years. But these aspects, these differences were not mentioned in any publications. The importance values of the two archive surveys and the importances of the present survey are greatly varying. There are two columns, the two blue columns with the original values, and the 9 columns for our 9 geosites, the examined geosites of the Balaton uplands in the right part of the table. You can see the importance value, the original, our surveyed importance values are greatly varying at each geosite. The geosites, these are only the main value indicators of the model. In the next slide, you can see the additional value indicators of the model. There is even a greater variance between the global and the local. Global values are the blue values, and the local values are the red values that we determined in the Balaton uplands. The determined values expressively refer to the character of a geosite. For example, the difficulty level of accessibility. If easy to access, a larger score. If harder to access, a lower score. Or it refers to the tourism infrastructure of a geosite. If the infrastructure exists, the geotourists gave a higher score. If does not exist an infrastructure, they gave lower score. So this table is very interesting because of the diverse scores that even the two original models give for the assessment, and we determined for each geosite through the questionnaires for the assessment. While the importance values for the study area represent the weight of the certain indicator, but by comparing the values calculated for the sites, a spatial variance of the indicators can also be given. For this, we use the var.p function of Excel. I mean, these are the indicators, the importance factors of the indicators in the first 3 rows, and the variance, the spatial variance, is in this lower chart. You can see the spatial variance determined in every indicator in the assessment. This means that Hungarian geotourists judge these values differently at every geosite. The 3 values in the red box shows that current condition, level of protection, and vulnerability indicators are nearly equally important for geotourists at all geosites. This means that they consider geoconservation as a tool for nature protection and resilience. They don't really make a difference between main values, but they differentiate more additional values. The individual importance values of an interviewed visitor produce a single modified geosite assessment model evaluation for the given site. You can see these blue dots on the screen. Each one of these blue dots is an individual assessment. The original geosite assessment model score was multiplied by every person's importance factor, and every person's importance factor produced a single assessment for the Koloska Valley in this example. Every blue dot is a single individual assessment in this figure. Because of this, the number of questionnaire fields is equal to the number of individual assessments available at a certain geosite. By plotting these unique assessments into a scatter plot diagram of main values on the x-axis and additional values on the y-axis, they are considered as independent variables. We can visualize how differently the interviewed visitors think about the geotourism potential of a geosite. This opens a huge gate of interpretation for us, and a huge way of numbers we can determine. We have determined 3 three variables at every geosite in our research. The R-square coefficient shows the goodness of the fit of a linear function, this red linear function of the personal assessment scores on the set of the blue dots. So the R-square shows how good this red linear function fits to this cloud of blue dots in this scatter plot matrix. This trend line fit shows with this trend line, with this red trend line, we will be able to draw conclusions about further development strategies. For example, this geosite, the Koloska Valley, has nearly the highest R-square coefficient value in the set of the examined geosites, and the steepness, the S number, is 0.797. This means that the site is nearly balanced. The visitors are equally satisfied with both main and additional values, but to a different extent. You can see that the differences between the assessment values on both axes. For example, this blue dot in the bottom of the evaluation got very low additional value points, but this at the top of the diagram got high additional value scores, and this could be told for both for the main value scores too. However, this S value, the less than 1 steepness, shows that the site would need consideration about enhancing the scientific interpretation and promotion to match the management plan with the visitors' expectations. Visitors' expectation is a very important thing about the geosite. Geopark should make very clear statements about the promotion in the promotion for the visitors. So the visitors should know what to expect at the geosite. If they don't know what to expect, they will give very diverse scores, because they may be disappointed or they may be very delighted with the things they saw at the geosite. The sigma value, this third value, the sigma square value, is the variance of the dataset. This value shows how the plotted values differ from the statistical mean of the whole set of fields of each geosite. So this gives the variance of these all blue dots from the arithmetic mean. It also shows the extent of the difference of the visitors' personal evaluations. Okay, so this was only one scatter plot matrix, but in the next slide I will show all 9 scatter plot matrices, and I will make this presentation even more difficult for you, because I will draw conclusions about the shapes of these point clouds that are determined by these blue dots. The large and isometric, so-called regular shaped clouds refer to the diverse interests, expectations, and scientific infrastructural needs of geotourists. This situation could be treated by clear, well-designed commercial material, internet sources, and interpretative panels. I told this initially in the example of Koloska Valley, but the Koloska Valley is not a really good example for this large and isometric cloud, but Lake Köcsi is yes, because you can see that it's a regular point cloud shape. They have the visitors gave very different assessment scores for the value for the geosite, and because of this, we can say that neither of the visitors or the field or the people who filled the questionnaire have clear initial views of the geosites. They didn't know what to expect in Lake Köcsi, next to Lake Köcsi. when they visited it. So they might be disappointed. They are the lower scores on the left side, or they might be okay with this geosite. These are shown by these upper blue dots in Lake Köcsi. If the point cloud is small and isometric, the visitors have quite similar opinions about the features of a certain geosite. In this case, each individual assessment gets nearly the same assessment value. So we can search for small and isometric point cloud. This is true for the Permian and Triassic key section next to village Chopak. It is a small and relatively isometric point cloud. As I said, this geosite is nearly only visited by experts of the geoscience field, and they are well aware of the things that the geosites can give us. So they nearly gave the same assessment for the importance value of this of the geosite. When the shape of the point set is not regular, we can differentiate the visitors according to the main values and additional values. We call these elongated point clouds. These point clouds could refer to different evaluation groups, which can be categorized by a linear function model fitted on the point cloud. So the linear function gets its role really in the case of these elongated point clouds. When analyzing these non-isometric elongated clouds, we can use the steepness of the linear function plotted on the score set. This steepness refers to the difference between the visitors' opinions. We can determine if there is a higher demand for scientific or a higher demand for infrastructural development when the steepness is greater than 1. For example, in the case of the meteorite, additional values, if less than 1, main values are more important for the visitors in general. Here is a part of a table that judges the geosites on their point cloud shape. The meteorite has an elongated additional values dominated point cloud. So the current state of the meteorite geosite has no tourism infrastructure despite the good main values. As I said, this meteorite is quite rare all over the world, and even in the geopark. It has good functional values because it is in the central part of Alsóörs, but it has no tourism infrastructure. It is not well promoted, so additional values are lacked in the case of this geosite. Lake Köcsi has large isometric point cloud, as I said before. The site is not well promoted. This is because this causes the large isometric cloud, so geotourists don't know what to expect at this geosite, and the tourist infrastructure is not really maintained correctly because there are ruined interpretative panels and benches next to the lake. But the situation could be solved with well-designed and clear commercial materials that could filter the diverse expectations of the visitors. The Vöröskő Nature Trail has elongated main values dominated point cloud. So the good additional values are because of the neighboring outdoor theater. The scientific values are not really balanced with it because the tourists' attention is got by the theater. They don't really recognize the scientific value just next to the theater, the scientific value of the abandoned red sandstone quarry. But a visitor center could make the balance between the main values and the additional values in the near future. And the Permian Triassic key section with the small isometric point cloud means that the main values and the additional values are well balanced. This is because the experts who visit this field regularly but the tourism promotion could be well of this geosite. They could make it easier to stop by a car. Making a parking lot would be very good for geotourists who are interested in a quite scientific rarity. Well, to conclude my presentation, we think that this numerical, mathematical, and statistical approach can help to preserve the uniqueness of each geosite. We found that the modified geosite assessment model universalizes the geosites in some aspects, but with the geotourist opinion, we can make these assessments unique in a sense. In this way, global values do not harm the unique features of the geosites, and as you saw, personalized development strategies can be established for each geosite. We plan to research on the effect of time. This gives further questions for us. What happens if a geosite becomes infrastructurally developed? How do the scores change in this case, or do the numbers show anything after the development? These data could show if a development has good or bad effects on a custom site. And to give a sight into the current research work, I can give you numbers about the current fields of the geosite. These are not part of this research project, but these are included in the next step. The blue bars are the original numbers, so the number of fields in the blue bars were counted in the research that I talked about in the past minutes, and in the orange bars, these are the new fields. And we supplemented the sample area with 4 other geosites in the Tihany Peninsula, and next to the Tihany Peninsula in Menchely, the volcano nature trail that is inside a volcano, and it is a famous place. So this is the cause for the large number of fields already in the geosite, despite the pandemic period in 2020. We plan to process these data after the first few months of 2021, hoping that geotourists will be able to visit these sites after the threat of coronavirus. Well, I would like to thank you for your attention. I hope that you understood at last something from this presentation, and I would be very happy to answer every question that you have. And in the future, if you would like to contact me, you find my email address in the right corner of the slide. So thank you very much.
Okay, thank you very much, Márton. It was quite interesting, and it's nice to travel a bit. So I think we have a first question from Benjamin. If you want to turn on your microphone.
Yes, I have. I don't know what my first question was because I asked quite a few. I have to go back. Where was I? I said welcome to everybody. Yeah, my first question was just a starter about the geopark itself. Why is most of the lake not included in the geopark?
Well, maybe because the lake is not interesting geologically.
Okay.
As you could see that a very small part of the geopark is in the southern shore of the Lake Balaton. This is because these Fonyód hills on the southern shore are of the same origin as the northern part of the lake. So geologically, pedologically, and geomorphologically, the southern part is not as interesting as the northern part.
Okay, fine.
Ben, you had a second one, or
I did, but Pal already answered it. So Marie Noel's the next.
Yeah, Marie Noel. if you want to turn on your microphone.
Yes. Hi.
Okay. Why did I
you
choose?
hear me at least.
Yes.
I just had first a follow-up question on Ben's question. What is the origin of this lake?
Sorry?
What is the origin of the lake?
It is in a fault. It is in a fault.
Okay. So it does have a link with the geology, right?
It has, yes.
Okay. That could be some way to link it with the geopark, right?
Yeah.
Yeah, my question, sorry. Also, I have to remember. Yeah, why did you choose these sites? You chose 9 sites? Is that you didn't show their distribution, for example? So I wasn't sure if these are supposed to be representative or just in an area specifically, or
we made a geosite assessment model evaluation preliminary to this experiment, and the geosite assessment model evaluation results gave us these 9 geosites that we chosen. I had 1 or 2 articles about choosing the geosites on maps and geopark sources, and fortunately these 9 geosites overlap with the experiences. So these are the 9 sites that are most visited in the eastern part of the geopark. Unfortunately, quantitative assessment has not been made before in the geopark before this work. So this work was able to prove that the geopark is founded on a solid basis, or at least its eastern part.
Right. There were some sound problems.
Yes.
Yes, like when in your scatter plots, I mean, except from the first one you showed, I think the other ones have had very low correlation.
Yes, they have
values there. So you think this also express the maybe the way that people do not really understand what the meaning of the sites, or if there's no correlation between their interest and the scientific values?
Well, I have an experience on this, personal experience. I have visited Lóci Cave that I mentioned in the presentation. It has a very beautiful set of tilted limestone layers, and many people think if they visit this limestone cave, they expect karstic processes in this limestone cave. They expect large stalactites, stalagmites, and they leave the cave disappointed because there are no these things. So the geopark should make clear commercial materials, that they should make clear for each geosite what to expect there, because the geoheritage and the geoeducation is founded on this basis. What scientific features should the geotourists expect at a site?
I guess you could explain why there are not these features. Why you have no stalactite. I mean, it could be an interesting point of view. Yes, the absence of it would be a way to teach or educate the people on what to create. Not every cave has them.
It is explained in the cave, but they don't know anything about the cave before they enter it. You should know that this Lake Balaton is crowded with tourists during the summer, but not with geotourists. They go into the lake and have fun on the shore. And if it's very hot, the weather is very hot, they try to find cooler sites, and the cave is an ideal place for some cooling in the summer. So it is tourists. The Lake Balaton is not really famous for geotourists right now, because the other parts of tourists, I mentioned the famous wines on the side. The tourists know more about wines, more about the lake itself, more about cultural values than the geopark and the geological features themselves, because the geopark is a relatively new thing. It is an 8-year-old thing in the Balaton uplands, and the geoeducation is not in this stage when these scientific values are spread all around the country.
So I don't know if we have to cut now, or I can continue for a lot of time.
You can.
Anybody else? Maybe.
Marie-Noël, there's a raised hand from Zibi in Poland, so maybe we should ask Zibi to ask a question.
Good evening, everybody.
Good evening, Zibi.
Yes, so congratulations for your presentation. Thank you very
Thank
much.
you.
And one question only. Why the JM method is so not popular in literature? I discovered that this method was used mainly in Central European countries. Are you agree?
Yes, it was. I don't know why. I think it's a very good method, but yeah, I found no Western European, for example, Western European publications about the GAM. But as I looked at the French method, for example, it has a very large correlation with it. So they are similar in a way, but I don't know why it is not used. I don't know.
Okay, thank you very much.
Okay. So I think we have no more question, or maybe Ben, if you have some message.
I don't know. Marie-Noël still was wanting to ask questions.
You have one question.
And I have one, yes.
I'm back on. Yeah. Say, you think tourists do not really know about the geology, or so what do you think is would change this? What would be a good way to introduce them to that? Is that only infrastructure?
We have different things that we try to spread scientific information for tourists. For example, as I am a cartographer, we made with my supervisor a geological hiking map of currently this area, of exactly this eastern part of the area. This could be, for example, a tool for spreading geological information for tourists. Geological hiking map, this map genre is a relatively young map type. We can give information through this, and I have made a digital version of this paper map that the Geopark published 2 years ago. I think it was published 2 years ago. I have made a digital version from this map that the Geopark used for some time, and that was also a tool. We did what we can, but the Geopark, we are unfortunately, the university is not the Geopark. I don't know how could we catch the tourist attention. Maybe with very good and spectacular videos, or I know that there are classes at school held by the Geopark staff in the villages and cities in the Geopark, and there are geotours all over the Geopark. It is a relatively big Geopark, so there are 4 or 5 areas, I think, which has designated geotour guides for that area, and there are also a lot of participants, and they are aware of the scientific facts, but there are others who don't.
Do you think those who answered the questionnaires are those that are more interested in the scientific?
Yes,
or do you have
because
an idea?
it is a quite long questionnaire. It includes 27 indicators, and it consumes at least 15 minutes to fill the questionnaire. So the person who filled this questionnaire is, I'm sure he or she is interested in the scientific facts. And I made a field where they could give their email addresses where I sent them the results of this research and in the end of the process. So they must be. I'm sure they are interested in. If someone is not interested, he or she did not fill the questionnaire, I think.
Mm-hmm.
Okay, thank you very much, Márton, for your answers.